Hi, hello, welcome to my channel Jadov Civil Academy. If you are watching my videos for first time, please like, share and subscribe my channel. In this video, we are going to discuss about previous questions in TS E-CET 2020 pertaining to the subject engineering mechanics. So let us start our discussion. Here the first question asked is in the engineering mechanics for two forces in a member to be in equilibrium, the forces have to be, it means here we have a member. To keep this member in equilibrium, the two forces are acting. Then what are the characteristics of two forces to be keep that body in equilibrium? So let us take the two forces, say F here and F another force here. These are two forces. Under the action of these two forces, this body is under equilibrium. So how these two forces are? This is F and this is also F. They are equal in magnitude. What? Equal in magnitude. Equal in magnitude. Equal in magnitude. And how they are in direction? They are equal. They are opposite in direction. They are opposite in direction. And if you draw the line of action of these two forces, so this is the line of action of this force, right? And this is the line of action of these two forces, right? The line of action of these two forces are same, so we can call that force is a collinear force. That force system is what? Collinear force system. And finally, these two forces are acting in the same horizontal plane. So when the forces are acting in the same plane, we can say these are coplanar forces. What are those called? Coplanar forces. So finally, so to keep this body in equilibrium, under the action of these two forces, these forces have to be equal in magnitude, opposite in direction, and they must be collinear and they are coplanar. So let us see the option. Option A, only equal and opposite? No. Only collinear and coplanar? No. Only equal and collinear? No. They are equal, opposite in direction, collinear and coplanar. So the answer D is option D is correct for this question. So let us see one more question here. In the figure shown, the length of AB is A. What is the couple due to both parallel forces of magnitude F? So before explaining this problem, I will explain what is the couple is. Suppose it is a plane body. Over that body, a two equal and opposite forces, or I can say unlike parallel forces. So this is one force of F, and I have on the same body another force, that is F here, right? They are equal in magnitude, opposite in direction, but they are acting at some distance apart. So this is point A and point B. So distance between this point B to A and point A to B is same. And at point A the force F is acting, and point B is the force, same magnitude force F is acting. So they will form a couple, and the distance between these two is, say, small a, for example, small a. Now it will form a anti-clockwise couple also a moment, so that is F into A, right? So in this definition, our forces are making angle 90 degrees with the axis, but in our actual problem the forces are inclined forces. So to calculate the magnitude of the couple, so we have to resolve these inclined forces into a rectangular components. So let us start resolving the forces. So here at point A, the force is acting in this direction. Here the angle is theta, means here also angle theta. right? And if you resolve this force into horizontal component and a vertical component like this, horizontal and vertical component like this, now it is making angle with a vertical axis. So the vertical component will become F cos theta. What is the vertical component will become? F cos theta, and horizontal component will become F sin theta. F sin theta. And similarly, resolve the forces at point B. Here, this is a horizontal component of force at point B, and this is a vertical component of a force at point B. Again, this F also making theta with vertical axis. So the vertical component of force will become F cos theta, right? And this will become F, horizontal component of force will become F sin theta. So if you observe this horizontal component of forces F sin theta and F sin theta, they are equal in magnitude and opposite direction. So they will get nullified. And the distance between this point A to B given is, say, A. What is that? A. Now the finally we have left with this force and this force, and it is a point A and this is a point B. The component of this force is F cos theta, and this also F cos theta, F cos theta. The distance between these two is A. The distance between these two forces is A. Then it will form a couple. Now the two equal and opposite forces are acting at some distance apart, that is A. Then it will form a couple. Couple is a moment, that is force into perpendicular distance. So the force is F cos theta and the perpendicular distance is A, right? So we will get the magnitude of this couple is Fa cos theta. What is that? Fa cos theta. So let us see the options here. Option A is Fa sin theta. It is not a right answer. Option B is Fa tan theta. It is not a right answer. And option C is Fa cos theta. So it is a right answer for this question. So let us see one more question here. So what is the location of centroid of isosceles triangle of base 60 and side 50 centimeter? From the base we have to calculate what is the centroid of this isosceles triangle. You know, isosceles triangle means these two sides are same. So the base, let me indicate the points A, this is B, and this is C, and AC is the base here. What is the base value? Base, the dimension of base is 60 centimeters, and the dimension of this side is 50, and this is also a 50 centimeters. 50. So AC is 60 centimeters, AB is 60 centimeters, and BC is 60 centimeters. So as it is an isosceles triangle, for isosceles triangle, the centroid is lies at a distance of h by 3 from the base. A distance of h by 3 from the base. As it is a symmetrical y-axis and y-axis, so the centroid lies on y-axis, y equal to h by 3. But in the problem, they have given only sides of the isosceles triangle and base of the isosceles triangle. They are not mentioned about the height. But we need to calculate here what is the height of this isosceles triangle is. What is the height of this isosceles triangle? H is. If you know this height, then you will get your solution. So this is the height we have to calculate. So now I will divide this triangle into two right angle triangle. Okay, and this is 90 degrees here, and this is a point D. To calculate height, that is BD, I will take any one of the part of right angle triangle, and if I apply the Pythagoras theory, so I will get what is that height of that isosceles triangle is. So here I am drawing one of the part of isosceles triangle, that is right angle triangle. So this is A, right, and this is B, and this is D. Okay, and as it is AC is 60, now AD will become 30 centimeters. This is 30 centimeters, and this is a 50 centimeters, and this is height H. This height we need to calculate. So now as it is a right angle triangle, apply the Pythagoras theory here. We'll get in this is a what hypotenuse, adjacent side and opposite side. So this is say making theta here. So this is opposite side, adjacent side, and AB is a hypotenuse. So AB square, if I write the Pythagoras theory here, AB square is equal to AD square, AD square, it is a D, AD square plus BD square plus BD square. Now substitute the respective values. AB is what? How much? A 50 square. AB is 50 square is equal to, and AD is 30 square. AD is 30 square, and BD is H. So this H we have to calculate now. BD square, H square. From this, H square is equal to 50 square, 50 square minus 30 square, right? 50 square nothing but it is 2500, right? And 30 square nothing but it is 900. If we deduct this 900 from 2500, we will get a 1600. So H square is 1600, then H would become under root of 1600. Under root of 1600, right? It is equal to how much? It is 40. So height we got from this simple calculation is 40 centimeter. So the centroid of isosceles triangle lies at what distance from the base? It is y bar equal to h by 3. Y bar equal to h by 3. That equal to h is here how much? 40. 40 by 3 we get, if you simplify this, 40 by 3 we get 13.33. How much? 13.33 centimeters. 13.33 centimeters. So for this question, the option B is the correct answer. Okay, so let's move on to the next problem. Here it is a simple question. What is the location of centroid from the bottom of a T section as shown in figure below? So this T section, if you observe that this T section is symmetric about the y axis, so our centroid lies on the y axis. So here centroid we have to calculate from the base. To calculate the centroid, here we have a T section. This T section will be divided into two rectangular sections, that is rectangle 1 and rectangle 2. For this, for rectangular 1, we have to calculate what is the area A1. Area, as it is a rectangle, we have B into D. So B is 2 centimeter and D is 10 centimeter. So B into D is nothing but 2 into 10. So 2 into 10 we get 20 centimeter square area. 20 centimeter square area for rectangle 1. Similarly, what is the centroid of this from the base? So as it is a depth for rectangular section, the centroid will be half of that depth, lies at the half of the depth. So this is, assume that this is half of the depth. So what is the total depth? the centroid is y1 here. I can write y1. This is y1 for the rectangular one. So it lies at half of the depth of the rectangle. Y1 is equal, so d by 2. What is the d here? 10 by 2. So it will become 5 centimeter. The centroid of first rectangle is 5 centimeter from the base. And similarly calculate the area of second triangle. The B is 20 here, 10 here, and depth is 2 centimeter. So area is B into D. So area A2 equal to B into D. B is 10 and D is 2. So 10 into 2 will get 20 centimeter square. 20 centimeter square. And the center of this rectangle lies at the center of this rectangle. So this here from the base we need to calculate what is the center of second rectangle. So this height we have to calculate, that would become the center of second rectangle. So up to here we have a 10, and at this, as it is a rectangle, the center lies at the half of the depth. So 2 by 2 we have. So 2 by 2 is 1. So 10 plus and the centroid of that second rectangle is 2 by 2. That will become half depth. It will be lies at half depth. So 2 by 2 is 1. So finally we get y2 equal to 11 centimeters. Y2 equal to how much? 11 centimeter. Let me write here. So y2 equal to 11 centimeters. Now simple. I have calculated what is the centroid of rectangle 1 and rectangle 2. Now just apply the formula for calculating a centroid of total I section, that is y bar equal to a1 y1 plus a2 y2 by a1 plus a2. Okay, now substitute simple all those parameters in this formula. A1 is 20, and y1 is how much? 5, and plus a2 is 20 and y2 is 11. It is 11. And a1 is 20 and a2 also 20. So 20 plus 20 equal to sum of the area is 40. Okay. Now from above, if I simplify the above step, that if I take here 20 is a common, then I will get 5 plus 11 by 40. 5 plus 11 by 40. Here 21 jar, 22 jars. 22 is how much? 40. Finally we get 5 plus 11, it is 16. 16 by 2, how much? 16 by 2 is 8 centimeters. 16 by 2 is 8 centimeters. So the center of this T section is 8 centimeter. So option B is correct for this question. Okay. So we'll solve next one more question. So what is the formula for theorem of perpendicular axis theorem? So if I explain you the statement of perpendicular theorem, so when we have a lamina, a plane figure, this is the x-axis, the moment of inertia about this x-axis is ixx. What is that? Ixx. And this is a y-axis, the moment of inertia about this y-axis is Iyy. We have one more axis, that is z-axis. That is the moment of inertia about this axis is Izz. The moment of inertia about z-axis is equal to sum of the moment of inertia of other two mutually perpendicular axes. What is that? The moment of inertia about the axis which is perpendicular to the plane figure is sum of the moment of inertia of the other two perpendicular axes. That is the statement of perpendicular axis theorem. So the moment of inertia about z axis is izz is equal to sum of the moment of inertia about other two perpendicular axes. What are the other two perpendicular axes? X axis and y axis. The sum of these two moment of inertia of these two axes is ixx plus iyy. Ixx plus iyy. So this is the statement of your perpendicular axis theorem, and this can be written as it is this can be written as iyy is equal to what? Izz iyy is equal to izz, and if you take this ixx to the side of is equal to, then it will become minus, so that is ixx. What is that? Ixx. So let us see the options here. The first option is, so it is not a correct right option, and second option is a parallel axis theorem, it is not a right answer. But see, if third option is izz equal izz minus ixx is equal to iyy. So same answer we got here. So the formula for theorem of perpendicular axis theorem is option C is the correct answer for this question. So let us see one more problem here. It is a very important problem. But if you see here, the problem seems to be very lengthy, but I will explain in a very tricky manner to solve this question. What is this question? The moment of inertia of I section given below about its major axis is. So as this I section, if you observe that it is symmetric about y axis and it is symmetric about x axis, it is symmetric about x axis and is a xx axis, and this is your y axis, yy axis, right? Yy axis, right? As it is symmetric about both the axes, to calculate the moment of inertia of this symmetrical I section, what we'll do first, we have to convert this whole section into a rectangular section, right? In this rectangular section, what we have, these two smaller rectangles. So outer rectangle is bigger rectangle, so this is a bigger rectangle, and inner we have two smaller rectangles. If you, this is one more rectangle and this is the second rectangle. So this is one smaller rectangle, two is second smaller rectangle. So to calculate the moment of inertia of this I section, if first you have to calculate moment of inertia of the bigger rectangle, that is BD cube by 12, right? And then we have to calculate moment of inertia of these two smaller rectangle, and if we deduct the moment of inertia of these two small rectangle from the moment of inertia of the bigger rectangle, then we'll get what is the moment of inertia of a I section. So let us do that thing. So as generally we'll take the major axis is ixx, 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 it is equal to the moment of inertia of bigger rectangle, that is BD cube by 12, that already this formula is known to everybody, BD cube by 12, okay, right. This is the moment of inertia of larger rectangle. If you deduct the moment of inertia of two smaller rectangles, that is 1 and 2, I can write 2 into small b d cube by 12. Here small b is the width of small rectangle and small d is the depth of a smaller rectangle. So let us write what is b. Capital B is here. Capital B is how much? 10 centimeter. So this is capital B. It is a width of bigger rectangle, and capital D is say This is a capital D. This is a capital D. So 10 centimeter. And small b is so width of this, right? It is total 10 minus 2, it will become 8, and 8 by 2 will become 4. So this is 4 centimeters and this is 4 centimeters. So width of the smaller rectangle is 4 centimeter and depth of the smaller rectangle is, so total depth is 10. Deduct this 1 centimeter and this top 1 centimeter. Now it will become your 8 centimeter. It will become 10 minus 2 how much? It is a 8 centimeters. So small d is equal to how much? 8 centimeters. Now substitute all those values in this equation. You will get, that is b is 10 into capital D also at 10. So power 3, 10 cube by 12. Okay, and minus 2 into, what is small b value? Small b is 4 and d is 8. So d power cube means 8 power cube by 12. This is 12. Right. If you simplify this, we will get 10 power 4 by 12 minus 2 into 4 8 and 8 cube. So it will become 8 power 4 by 12. Right. Among all these things, you please take out LCM 1 by 12, take out the common 1 by 12 of 10 power 4 minus 8 power 4. So you will get the moment of inertia of a symmetrical I section about major axis is 492 centimeter square, centimeter power 4. The units of moment of inertia is centimeter power 4. So these are the solutions for in the subject engineering mechanics which were asked in TS ECET 2020 examinations. Thank you.